Now in the real beam and the conjugate beam it is there. Now you can explain what are exactly the conditions. Now real beam is the question paper and the questionnaire. Now in the conjugate beam, which we are going to convert into the conjugate beam. Now if the support is having the fixed end, that support is converted into free end. I repeat, if we have the support is having the fixed end and that fixed end is converted into free end, again the free end we having, that free end is converted into fixed end. If it is a roller, then it is also a roller. If it is a pin, it is also a pin. Suppose if it is an overhang beam, the intermediate support is having the roller or pin, that is converted into internal hinge. I repeat, there it is an overhang beam. For this overhang beam, we converted into the internal hinge. Means it is intermediate support, that intermediate support is converted into internal hinge. Now we go for the figures. In A and B is a cantilever beam. A support is having the fixed support in the real beam. Same the conjugate beam is nothing but A support it's converted into free end and free end B support is converted into fixed end. Now what is understood? That this is the condition. If it is a fixed, it is converted to free. If it is a free, it's converted into fixed. A is having fixed, A becomes free. B is having free, B becomes fixed. Same here, same. A is having free, B is having fixed. So in the conjugate beam, A becomes fixed, B becomes free end. This is the normal simply supported, which having the roller support and simply supported. There is no changes in the roller and simply supported. Now go for overhanging beam. A support is a free, B support roller support, C support is a simply supported, where B is an internal support. So A becomes your fixed one, B becomes your internal hinge and C remains same because it is an simply supported. Suppose if your questionnaire carries the internal hinge, that internal hinge will convert into the roller support and fixed will convert into the pin support. Okay, so this is the condition you need to follow. Thank you. Okay, now we'll start a new problem. That's the first problem. Example number 1. Calculate the deflection at A by using conjugate beam method as shown in the figure. See, this is the figure. The cantilever beam carries L, length of L, and carries the load at P at A. Now this is the real beam. Now step 1, write down your real beam. This is the real beam, this is point B, point A, and point load P is acting at the point A. Now for this, step 2 is you need to find out what is the moment at B. What is the moment at B? What is the moment at B? P into L. P into L. What is P? Minus P into L. That is minus PL. That is minus PL. For this, we need to draw the BMD. The second step is draw the BMD. So this is the real beam. For that real beam, the BMD we are writing. Okay. So next step is, step 4 is draw BMD for dividing the EI diagram. Means M by EI diagram we are drawing. Next step, draw the conjugate beam. I told you the conditions are free end converts into fixed end and vice versa. See, what is the conjugate beam? A support is having free end, so that becomes fixed end. B support having fixed end, that becomes free end. Bending moment is negative, so we are used to draw the BMD below the x-axis. Okay, this acting negative, so due to this negative, we are taking this and attaching to the given real conjugate beam. This is conjugate beam and we are attaching this as a load case. This as a load case. Now what is the new thing here? Here you can see the moment at A and the force VA. The load is PL by EI is the load. Now to find out the bending moment at A. So bending moment at A and VA we need to find out. What is that? bending moment at A is equal to ma, the moment A, plus half into PL by EI into length, that is the area of triangle, into the centroidal distance, that is 2L by 3, area into centroidal distance about point A, that is 2L by 3. So total, what is that answer we are getting? MA is equal to minus PL cube by 3EI. So finally the moment of conjugate beam is equal to deflection at that point. Deflection at that point. If you draw the elastic curve, due to this, what will be happening? Like this it will be. So this is the deflection. Where is the deflection? At A. So what we got here? Moment at A means moment is of the conjugate beam equals to deflection at that point. So deflection of this and moment at this is same. Okay, thank you. This is the first question. Go through it. Next problem. Using conjugate beam method, determine the maximum deflection and the slope at supports for a simply supported beam subjected to UDL of W kN per meter run over the span of length L with the constant EI. Okay, so this is the questionnaire he has given. First, draw the real beam. The real beam is what? The simply supported beam which carries the W kN per meter of length L, and he told the midspan, that is at C point. Okay, first step for the real beam, we need to draw the BMD. Easy, you already know how to draw the BMD and M by EI diagram. I'll just go through very fastly. Find the reactions and draw the BMD is a step 2. So sigma B is equal to 0, MB is equal to 0, RA into L minus W into L into L by 2. That is RA is equal to WL square by 2, and moment at C is equal to what? WL square by 8. WL square by 8. So MC we got. So draw the BMD, that is WL square by 8 by EI. So we are making the M by EI diagram. Now you should draw the conjugate beam. What is the conjugate beam? Any conditions? For simply supported beam, there is no change in supports. As per conditions, this is the, suppose if this support is a pin support or roller support, there is no changes. For simply supported beam, there is no change in the conjugate beam. So we have taken the BMD and we are placed as a load. Okay, we are placed as the load. What is next step? Find the reactions and bending moment at C for conjugate beam. Why bending moment at C? What he asked to slope at the support and maximum deflection. Where maximum deflection will occur? In the simply supported, the maximum deflection will be occurring at the midspan. Now we go through it. RA is equal to RB is equal to theta A is equal to theta B. That is, if we find out RA and RB, that becomes the slopes at that supports, because it is the same EI. And what is the deflection? Deflection we need to find out at C, that is bending moment at C. So RA and RB, how are you going to find out the RA and RB? RA is equal to RB, that is equal to area half into area of parabola, that is W cube by 24 EI. Okay, RA is equal to RB, that is the load. What is the load? It is total load is half of the section into area of the parabolic section. So RA is equal to RB is equal to W cube by 24 EI, that is theta A and theta B. Okay. See, for that explanation, For parabola, convert into point load, that is area of parabola. What is area of for a parabola? 2 by 3 into L into WL square by 8 EI. So point load acts midpoint of the simply supported beam. So that is the explanation is here. Moment MB is equal to 0. RA into L minus 2 by area of parabola into L by 2. So that is RA is equal to W cube by 24 EI. The same thing, you have to find out the reactions of RA and RB. Now very simple, you need to find out the moment at C, that is deflection. So what is that? So here there is a C and this is the parabola section which carries WL square by 8 EI. That is we have A and B. We know RA and RB. So RA into L by 2, RA into L by 2 and 2/3 of L by 2 into WL square by 8 is the area, and centroid of the parabola is 3 by 8 L by 2. 3 by 8 L by 2 is the centroid of the parabola. Therefore, final deflection is equal to 5 WL pi by 4 divided by 384 EI. That is the deflection of UDL over the span of length L for the simply supported beam. Clear? Now finally, the theta A is equal to plus W cube by 24 EI, theta B is equal to anti-clockwise W cube by 24 EI, and deflection at C is equal to 384 EI. So you can go through this, guys.